Alright, so let me just do this quickly. Alright, so let's say we have the 192.168.10.0 network, and then we have another one, 192.168.11.0. So what you do is you have to put this into binary. 192 is 1 1 1 2 3 4 5 6. 168 is what? 1101. Yeah, 1 0, because it's going to be 128 from 64. You'll have 40, so 32 can go. You are left with 8, I think. 32 out of 40, yeah, you are left with 8 0 1 0 0 0. Okay, so that is what 168 is. 10 is 0 0 0 0 0, sorry, 1 0 1 0, and 0 is all zeros. Right, another one, 192 again is the same. 1 1 1 2 3 4 5 6, sorry, dot 1 0 1 0 1 0 0 0 dot 0 0 0 0 1 0 1 1. That is 11. Okay, and then all zeros. Now I have to AND this. Okay, I have to AND, and ANDing is important. Sorry about that. I think my hand is not so straight. Alright, so when I am to AND this, the most important thing right now is that I have to know which bits matched as 1 and which bits doesn't. So in this scenario, I have a bit that doesn't really match. Let's say, for instance, I have all these bits matches 1 1, and then all the zeros are equal. Nothing, no difference. And here also I have 1 0 1 0 1 0 0, because they're all the same, no problem. You can see that they all matches. And this other one, 1 2 3 4, the fifth one matches, the sixth one matches, the seventh one matches, but the last one, it does not match. You can see that this one and this one, they don't match, so therefore you have a 0. So that 0 0 0 0 0 0 0 0. Now I have this. Now this is exactly what I did. So I just summarized my network. Now after summary, I have to convert this binary into decimal. That is my summarized binary. I need to put it into decimal. So if that happened, what is my address? My address is 192.168.10.0, because when I summarize this thing, I put it back into decimal, I get 10.0. Now what will be my CIDR? Your CIDR will always have to be the last matching bit. So you have to look at the bits from the left towards the right until you meet the last matching bit. So let's take an example. I'm gonna take from here. Okay, I take this, I move with it until I get the last matching bit. I drop it there from the left. Then here is my last matching bit. That's my last matching bit. Good. So that's my last matching bit. So my last matching bit from there down to the left hand side, you count the number of bits there, whatever it gives you, that should be your CIDR. So when I look at this is 8 bits, and this is 8 bits, that is 16, and this is 7 bits, that gives me CIDR 23. So my CIDR becomes CIDR 23 after I summarize that 192.10 and 192.168.11.0 CIDR 24 addresses. So I hope you guys pick this one. I'm going to give you guys an example. I want you guys to do this one for me. These are the networks I have. I have 172. Let's say 21.22.0 CIDR 24, and we have 172.16, sorry, .21.23.0/24. That will be your assignment. You have to do this one. 172.21.20.0 CIDR 24. So those 3 networks, assume that you're going to have to summarize these 3 networks together. So that's your assignment. Summarize those 3 networks together, and then you get back to me. Next we go. We have a create backup, that is the floating static route, and we explained that one before. So we're gonna have to do the configuration, and we'll explain all this. A default static route matches all packets and is used when a packet does not match a specified route in the routing table. So it's always used for that single purpose. Okay, so you use the default static route if you are connected to a stop network, like I was explaining before. So when we're doing our practical, we're gonna do this. So I summarized and I showed you guys how to summarize. So a floating static route is used to create a backup path if in case the normal route goes down. So what you do here is that you are going to increase the administrative distance of the main path higher than the main path. So for instance, you have a backup route, you want packets to move from, let's say for instance, a particular destination. You're gonna have to say, okay, this one. So let's take an example. Let me just make an explanation. Let me just take a new page and then I draw that. Let's say for instance, no, not history, I want to check this. Let's say I have this as my router. Okay, I have another router here, I have another router, I also have another router. So I connect these routers together. I connect this one here, and last but not the least, I also connect this router. Now what I want is that my router should take this. Now let's say for instance, here is my source packet, it's my source of the packet, and the packet goes right here, right there, and that's my destination packet. Okay, that's the destination of my packet. Right, so that's a very bad D. So that's the destination of my packet and that's the source. So I'm going to tell my router that anytime you have a packet, this should be your primary route. Okay, now this other path right at the bottom here should be your secondary route. Now how do I do this? Is that all routes from this router, that is the originating router, for instance this is router 1, from this originating router to the router 4, for instance if this is 4, alright, at the back side here. So you're telling the router always use this link up here. Maybe let's say for instance this is router 2. So you're saying to router 1 that you always use router 2 as your next hop to forward packets to router 4's LAN, and then use router 3 as a backup. Okay, so let's just make an example explanation. So router 3 down here should be the secondary. How do you do this? You are going to leave this route, okay, this route's administrative distance to 1 because at its default to 1, and increase the administrative distance of this other route to a distance higher than this normal static route, so that it will be floated. Okay, it will be floating on router 1. It will not be seen on the routing table. A floating static route is not shown in the routing table until and unless the primary route goes down. So if this link goes down, then the floated static route now will now activate, and then it will now be in the routing table. So it remains floated until at any time that the main route goes down. So that is one important aspect that we are talking about here. So we continue. So that's the default static route configuration. So all of these ones are practical explanation. So when I'm doing practical, I'm going to make sure that I explain all of these things. So I will tell you why I'm configuring using the next hop and an exit interface, so you can see the difference between all of them. So we're going to configure this type of stuff. So directly connected static routes, we have directly connected static routes, we have fully qualified, fully specified static route. A fully specified static route contains both the exit interface and the next hop. So I'm going to explain this one to you guys when I'm doing the practical side, okay, the practical aspect of this whole thing. So we have a default static route. It's a static route that matches all networks and all destinations, so you can do that. So there's not much that we can do here because everything here is all about practical and practical. So this is IP version 6 side, so we're going to go back to IP version 6 at a later time when we are done with this whole thing. So let's go to the final side. This is the floating static route, and I just explained floating static route. I said that you do it when you want a backup path to a primary route. So that is basically all that we need to discuss in this particular scenario. So I hope you guys followed me and then enjoyed my video. So do follow me on the practical side, and